first and then rationalize. Okay, both ways work out perfectly fine. If you were to square this first, you're going to get 4 over, and then you have 3 plus I times another 3 plus I. And so 3 times 3 is 9. 3 times I is 3I. 3 times I is 3I. I times I is a negative 1. So now you're going to have 8 plus 6I. I personally would have probably rationalized first and then squared it, but since the majority of you squared first, this is why I'm doing it. Okay, so now what you want to do is from this point, I can't leave it like this. I have to rationalize. So if I have a binomial 8 plus 6I in the denominator, what am I going to multiply it by to get that I to go away? You got it, 8 minus 6I. So now remember, when you have an A plus BI times an A minus BI, we're going to end up with an A squared, not minus B squared. What do we get? A squared plus B squared. So we're going to end up with an 8 squared plus 6 squared, all over 4 times the quantity of 8 minus 6I. So now we're going to get in our denominator 4 times the quantity of 8 minus 6I, all over 64. Oops, why did I write it like that? Plus 36. So we keep going, and we're going to get 4 times the quantity of 8 minus 6I, all over 100. And then we can simplify. 4 goes into 125 times, and that's how we get 8 minus 6I over 25. Does anybody want to see how it would have looked if I rationalized first and then squared? Are we okay? We're okay? Okay. So today we're going to go to higher powers of I. So as of yesterday, we knew that I was the square root of negative 1, and we knew that I squared was negative 1. We need to bring more powers into this. So if I have, let's write higher powers of I. So we know I represents the square root of negative 1. We know that I squared from yesterday is negative 1. Now let's talk about I to the third power. Well, if I is the square root of negative 1, I to the third power is the square root of negative 1 times the square root of negative 1 times the square root of negative 1. Do we agree? Well, square root of negative 1 times the square root of negative 1 is just negative 1. Root negative 1. Well, don't we know that the square root of negative 1 is I? So I to the third power is just negative I. And then we have I to the fourth power. Well, I to the fourth power is the square root of negative 1 times the square root of negative 1 times the square root of negative 1 times the square root of negative 1. Well, square root of negative 1 times square root of negative 1 is negative 1. Square root of negative 1 times the square root of negative 1 is negative 1. And what's negative 1 times a negative 1? Positive 1. So we need to memorize all of these. We need to know everything from I down to I to the fourth power. Okay, let's do some sample problems. Okay, so I to the fifth power. Well, we know every 4 i's multiplied together makes what? Is the equivalent to 1, right? Every 4 i's multiplied together is equivalent to 1. So I to the 5th power is 1, 2, 3, 4, 5 i's together. And we know every 4 multiplied together is 1. So we're just left with 1 times I, which is just I to the 1st, or just I. Okay, what about I to the 6th power? Well, I to the 6th power, again, is I multiplied together 6 times. So we know every 4 is 1, and then we're left with 2 i's left over. Well, what's I squared? So I to the 6th power is the same as 1 times I squared, but what's I squared? -1. You got it. Any shortcut instead of writing the i's out so many times? Any shortcut? What can we do?
I feel like division, and whatever the remainder is, that's like the exponent.
You got it. So we're going to take the exponent on I, and since we're trying to basically create groups of 4, why are we trying to create groups of 4 i's? Because every 4 i's multiplied together is 1. So we're creating 4 groups. We're trying to create 4 groups. So what we do is if our exponent is higher than 4, then we're going to take that exponent and divide it by 4, and whatever that remainder is becomes the new I, the remainder on the new I, and we just simplify that. So let's do another one. So if we're looking at I to the 7th power, do we agree that 4 goes into 7 one time with a remainder of what? 3. So now I'm left with I to the 3rd. But what's I to the 3rd power? -I. Okay, what about I to the 20th power? Well, 4 goes into 20 how many times? 5. Is there any remainder? No. So what does that mean? It's just 1. You got it. Okay, I to the 46th power. Ariana. You're okay? Okay, so I to the 46th power. Well, 4 goes into 46 how many times? 12 times, right? With a remainder of how much? I'm sorry, not 12 times, 11 times with a remainder of how much? 2. So do we agree this is the same as I to the 2nd power? And what's I to the 2nd power? -1. Okay, you guys do this one. I to the 27th power. Who simplified this for me? What'd we get? Amanda? You got it. -I. Does anybody need to see us do this? We're still simplifying. So I see some powers of I, so immediately my i's go there and I want to simplify them. So I leave 1 over 2i for now. And then I have 1 over 3i squared, but what's I squared? -1. So do we agree this is 1, or are you guys okay if I just assign that negative to the numerator? -1 over 3. And then I have 1 over 4i squared, but what's I'm sorry, not I squared, I to the third. But what's I to the third? -I. So again, are you guys okay if I assign that negative to the numerator and have, oops, 4i in the denominator? Okay. Still a problem. There's multiple problems. Our first problem is there's i's in the denominators. The other problem is, in order to subtract these or add these, whatever you want to call it, what do I need to create? A common denominator. How come I can't eliminate the denominator? How come that's not an option here? Ayana? Good. It's an expression. There's no equation. There's no equal sign with something after it to do the other side. So I can't eliminate the denominator. So I have to make a common denominator. Here's the question of the hour. Am I allowed to make a common denominator with I, or must I rationalize and then make a common denominator? What do you think? Let's rationalize. Let's always get in the habit of rationalizing, then creating. So let's rationalize our denominators. So for the first one, I just multiply by I, top and bottom. And the last one, multiply by I. So in my numerator, I have I over -2. I'm just going to assign the negative to the numerator again. And then I have 1/3, stays 1/3. And then I'm going to have a positive I over 4. Why did I change that a positive plus I over 4? Because the negatives canceled, because the I times I squared was a negative, and we already had a negative up there. All right, now can I create a common denominator? Yes. What is my common denominator for 2, 3, and 4? 12. So in the first fraction, I'm going to multiply top and bottom by 6 to create that 12. In the second one, I'm multiplying by 4. And in the third one, I'm multiplying by 3. And now I keep my denominator and I add my numerators. And so I have a -6i, I have a -4. And then a -6i plus 3i is a -3i. Can I pull out a GCF to simplify? Yes.
Pull out the negative and put it in front of the fraction.
You can absolutely pull out the negative and put it in front of the fraction. Do I have to do that though? No. Is there a number that I can pull out that would simplify with the denominator? No. So we leave it just like this. Yes.
I didn't, like, I found the common denominator before I rationalized on accident, but I got that in.
You got that. I know. The reason I'm saying is that sometimes, like for example, like what we did yesterday, if we had like the root of 12 over what did I say? Over 3i. Oh, sorry. What was it? Where we had to multiply. Now I can't remember. There was sometimes where if you don't rationalize first, it gives you the wrong answer. So that's why I'm always saying rule of thumbs, rationalize first, even though in some scenarios you don't have to. Does that make sense? So I'm just saying rule of thumb, just rationalize first so you don't get that hiccup. All right, let's keep going. So if I have I root 3 to the 4th power, can I distribute that 4 to the I and the root 3? Yeah, absolutely. How come I can distribute it to the I and the root 3? Because it's a monomial, exactly. So this becomes I to the 4th power. And then do you guys all agree the square root of 3 is 3 to the half raised to the 4th? Yes? Okay. So now power to a power, we multiply. We know I to the 4th power is what? 1. And then we're going to have 3 to the 2nd. Well, what's 3 to the 2nd power? 9. Can I distribute this exponent of 2? No, because it's a binomial. So what do I have to do here? Amanda? FOIL out. So we're going to have 1 plus I times 1 plus I. 1 times 1 is 1. 1 times I is I times 1 is I times I is I squared, which is -1. Do we agree the positive 1 and the -1 cancels? So I plus I is just 2I. So guys, I need you to memorize this. I need you to memorize that 1 plus I quantity squared is equal to 2I because it's going to really, really help with higher level problems that I'm going to show you in a minute, or higher powered problems that I'm going to show you in a minute. So if you memorize that 1 plus I quantity squared is equal to 2I, it's going to make things a lot easier. For example, for number 10, if I have 1 plus I raised to the 6th power, if I had to do this, what would it mean? Wouldn't it mean I'd have to FOIL out 1 plus I, multiply it times itself 6 times? That's a pain, isn't it? Or you can say, well, 1 plus I to the 2nd power raised to the what? 3rd power. Isn't this exactly the same? 1 plus I to the same as 1 plus I to the 2nd raised to the 3rd. Why did I manipulate it this way? Why did I manipulate it this way? Because 1 plus I quantity squared is what? 2I. And then if I'm raising a monomial to a power, isn't that a lot easier than having to multiply things out multiple times? So here we're going to have 1 plus I to the 2nd power we know is 2I. And then now we have 2I to the 3rd power, which is just going to be 8I cubed. Well, what's I cubed? -I. So this just becomes -8I. You guys do this one. Okay, what'd you get for 1 plus I to the 4th power? -4. Does anybody want to see us do this? Okay, now let's say I didn't make it 1 plus I. Let's say I made it 2 plus I to the 3rd power. Any shortcut there? No, we have to actually FOIL this out. So we're going to have to do 2 plus I times 2 plus I times 2 plus I. So I'm going to multiply 2 at a time. 2 times 2 is 4. 2 times I is 2I plus another 2I minus 1. So this is going to give us 3 plus 4i. And now we're going to take that 3 plus 4i and multiply by 2 plus i. And we're going to get 6 plus 3i plus 8i minus 4, right? Because I squared is a negative 1. So this is going to give us 2 plus 11i. Right, so there's not always a shortcut, right? But if it's a 1 plus I, we can try to manipulate it. Okay, so I just wrote, show that 1 plus I is a fourth root of negative 4. What do I mean by a fourth root? Lily? Good. It means that if I multiply 1 plus I and raise it to the, or if I take 1 plus I and raise it to the fourth power, what should that equal? Negative 4. Or if I take the fourth root of negative 4, one of its roots should be 1 plus I. So what we're going to do is we need to show that 1 plus I to the fourth power is equal to negative 4. Well, in this scenario, what am I going to do? I'm going to manipulate this. I'm going to write it 1 plus I raised to the second raised to the second should equal negative 4. Well, what's 1 plus I raised to the second? We just did this. 2i, and then 2i squared, negative 4. So did we show that 1 plus I is a fourth root? Absolutely. Is this factoring? Good. No, it's not. Why? Why is this not? How do I know this is not factoring? Violet? Good. There's nothing squared. There's no one exponent that's double the other exponent, right? They're both the same. They're both to a degree of 1. So since I'm solving for x, what I want to do in this scenario, I want to keep everything with an x on one side and anything that doesn't have an x move to the other side. So we have x plus 2ix equals 4. What do you think I'm going to do now on the left side? Ariana? Good. Pull out a GCF of x. So then I'm going to have 1 plus 2i equals 4. And since I'm solving for x now, I'm going to divide by the 1 plus 2i. So I have x is equal to 4 over 1 plus 2i. Can I leave my answer like this? No, we need to rationalize. So what am I going to multiply the 1 plus 2i by? Violet? 1 minus 2i. So in my denominator, I'm going to get a squared plus b squared, so that's going to be a 1 plus 4. In my numerator, I'm going to get 4 times the quantity of 1 minus 2i. So we have 4 times a quantity of 1 minus 2i all over 5. I can't simplify the 4 and the 5. If I wanted to, could I distribute in that 4? Sure. If I wanted to leave it like this, would this also be okay? Sure. Is this a factoring problem? Yeah, because we have an x squared and we have an x. All right, don't let that I intimidate you. We did problems similar to this with radicals, if you remember. So remember, when we're factoring, we need two numbers that multiply to the last number and add to the middle number. So I need factors of positive 6 that will add to a positive 5i. But the only way to add to I is if both factors have I in it. Do you agree? So we know I have to have an I times an I. And what's an I times an I? It's an I squared, which is a -1. So we're going to say -1 times what gives us a positive 6? -6. Okay. So now we know the factors here have to multiply to a -6. So now let's think about this. If I want to multiply to a -6, this is going to be our coefficients. We can do a -3 and a +2, right? But will a -3 and a +2 ever add to 5? No. So what are other factors of -6 that could add to 5? Amanda? You got it. We can do +6 times a -1. So here we're going to have +6 and a -1. Let's check this out. So 6i times a -I gives us -6i squared. Isn't that a positive 6? And now check here, 6i minus 1i, isn't that a positive 5i? So we guessed correctly. So now we're going to make our double set of parentheses and we're going to have an x plus 6i and an x minus I. Oh, did I say solve or did I say factor? Solve. Okay, so now this equals 0. Now what we do is we set each parenthesis equal to 0. So x plus 6i equals 0. So x equals -6i is one solution. And x minus I equals 0, x equals positive I is our other solution. Okay, I want you guys to try this one. Okay, so now we know in order to add to 2i, both factors need to have an I in it. And isn't an I times an I -1? So -1 times what will give us a +3? -1 times -3. So what does that mean? The coefficients have to multiply to a -3, but add to a +2. So do we agree that's a +3 and a -1? So now we're going to have an x plus 3i and an x minus I. How many people got those factors correct? Okay, good. And now you said equal to 0 and solve, so x will equal -3i and x will equal I. All right, last problem for today. Oh, because we're now introducing I into it. And so when the factors both have I in it, and I times an I is a -1, so that changes all of it. So we're still multiplying to a positive because 3i times a -1i is a +3. That's right. All right, last problem. It's not going to be pretty. Oop, that's not the fifth root. B. So that 5 is a coefficient of the radical. Does anybody realize anything? Even if you don't know exactly what to do with it, but do you notice anything? Lily? Oh, that's not an I, that's an x minus 1. Charlie?
Sort of.
Yeah, guys, I have this whole quantity to the first power, right? And then what is the square root as an exponent? It's a half. So then I have this whole quantity to the half power. So remember, what are the scenarios we can factor? The scenarios we can factor is when I have some base raised to an exponent that's double the same base, or one. If I have the same base raised to two different exponents, if one exponent is double the other exponent and their bases are the same, that tells us we can factor. I don't want to factor like this. This is very scary looking to me. So what I'm going to say is I'm going to let m equal the square root of x over x minus 1. So then this tells me I have an m squared minus 5m equals 6. So much less intimidating now, right? Yes. What do you mean? Oh, because I didn't let m equal the first power. I let m equal the power. Then I have to double m times m is an m squared. So now we're going to factor, so we're going to set equal to 0. So now we have an m squared minus 5m minus 6 equals 0. Easy peasy factoring, m minus 6 and m plus 1. So then we have m equals 6 and an m equals -1. Are we good here? No, because I use substitution, I have to substitute back. So now remember, m is equal to the square root of x over x plus 1 Yes. Oh, is it a -1? It is. That would have changed everything. Thank you. And now we solve. So to undo a square root, what am I going to do? Square both sides. So now I have x over x minus 1 is equal to 36. Now we solve. And we're going to have 36x minus 36 equals x. I just cross multiplied and distributed in. That's all I did. I'll have 35x equals 36. So x will equal 36 over 35. I will tell you, you would have to check this because it's a radical equation, but I will also tell you that this works out. This check works. All right. And this next one, let's just say you went and you squared both sides. X over x minus 1 equals 1. Then you cross multiply, x equals x minus 1. And then you go to solve. And the x's canceled. Can 0 ever equal -1? No. So this rejects. This one does not work. So our only solution is x equals 36 over 35. We are done for today.